So my calculations are that without using any gas or oil or fuel ever again from this day forward, that we would still exceed our maximum carbon equivalent greenhouse gas emissions, the 565 gigatons, by the year 2030, without the electricity sector even, or energy sector even factored in the equation, all simply by raising and eating livestock.
If you reduce the amount of methane emissions, the level in the atmosphere goes down fairly quickly within decades, as opposed to CO2. If you reduce the emissions to the atmosphere, you don't really see a signal in the atmosphere for 100 years or so.
Single largest contributor to every known environmental ill known to humankind. Deforestation, land use, water scarcity, the destabilization of communities, world hunger. The list doesn't stop. It's an environmental disaster that's being ignored by the very people who should be championing.
Free-living animals made up, 10,000 years ago, made up 99% of the biomass. And human beings, we only made up 1% of the biomass. Today, only 10,000 years later, which is really just a fraction of time, we human beings and the animals that we own as property make up 98% of the biomass, and wild free-living animals make up only 2%. We've basically completely stolen the world, the earth, from free-living animals to use for ourselves and our cows and pigs and chickens and factory farmed fish, and the oceans have been even more devastated.
Concerned researchers of the loss of species agree that the primary cause of loss of species on our earth that we're witnessing is due to overgrazing and habitat loss from livestock production on land, and by overfishing, which I call fishing, in our oceans.
We're in the middle of the largest mass extinction of species in 65 million years. The rainforest is being cut down at the rate of an acre per second. And the driving force behind all of this is animal agriculture, cutting down the forests to graze animals and to grow soybeans, genetically engineered soybeans to feed to the cows and pigs and chickens and factory farmed fish.
91% of the loss of rainforest in the Amazon area thus far to date, 91% that's been destroyed, is due to raising livestock.
In this video, we're going to discuss the sources, relative abundance, and effects of the different greenhouse gases. The ones we're going to look at are CO2, methane, dinitrogen monoxide, and water. Now, the sources of these, I'm put them in red and green. The red means they're human or anthropogenic, and the green means that they're natural. So the first one, we all know CO2 has come from burning fossil fuels. We need to get to a carbon neutral way of living within the century, or else we're doomed. And deforestation as well. Now the deforestation, as you saw in the video, quite surprisingly to most people, the World Bank found 91% of deforestation is from animal husbandry or animal agriculture. And funnily enough, most of the organizations right now that are environmental, they are focusing on palm oil. And while we do need to focus on palm oil, it actually is insignificant in comparison to the amount we've cut down for animal agriculture. Our forest fires and decay, like the decay of dead animals and plants, also produces carbon dioxide. For the next one, methane, the breakdown of grass in the animal stomachs, I put that as both red and green because, of course, there are animals in the wild that will produce methane naturally, and it's partly man-made because now, as you saw, we've sort of flipped the biomass, and there's a lot more animals that are methane producing than would exist in a natural sort of balanced ecology. So we've sort of flipped that around, and we also feed them now different foods. So we're actually growing a lot of soy, a lot of beans, and a lot of grains, and about half the food that we actually grow now doesn't go to humans, it goes to feeding livestock, and that tends to actually make those animals produce more gas than they would if they were eating a natural diet. So that's why it's both there. Same thing with rice paddies, and a lot of people don't realize rice paddies actually produce a lot of methane. And so we do a lot of intensive farming of rice paddies in many parts of Asia, so that causes actually some methane and obviously global warming. The dinitrogen monoxide comes from bacteria that exist naturally, also the nitrogen-based fertilizers that we now use to intensively farm. And the last one is water. Yes, water is a greenhouse gas, but very good differentiation to make here, is not all greenhouse gases are bad. For example, our Earth would not be habitable. It would be very, very cold without greenhouse gases. So water is one that we say does not contribute to climate change, but it does help us maintain a nice temperature on the planet. So let's look at comparing these in their ability to absorb infrared radiation. And so that again is keeping the heat in the planet, causing climate change. So if we look at this, this is all relative to carbon dioxide. So we'll find that methane, one molecule of methane versus one molecule of CO2, methane will actually absorb 30 times more, dinitrogen monoxide 160 times more, but water absorbs about 10 times less. But that's not the only thing to consider. Abundance, how much of it is actually in the atmosphere, is quite important as well. So 10% of our atmosphere is CO2, whereas 0.04% of it is methane, and 0.0017% of it is dinitrogen monoxide, and 0.0003% of it is water. So that begs the question of, okay, well, what does that mean? If one absorbs more but there's less of it in the atmosphere, how does that really help us measure its contribution to climate change? So what we do is we look at both the abundance and the ability, and then we come up with sort of a way to measure this. So methane is 30 times more effective at CO2 at absorbing radiation. However, since there's far less CH4 in the atmosphere than CO2, its contribution will end up being less than CO2. So let's look at those overall contributions. So here we are, CO2, 50% of climate change, anthropogenic climate change, coming from CO2. And that's why we have a big focus on it. But you'll see here, not far behind, 18% for methane. And as you saw in the video, methane is one that we should actually be targeting a lot more, because if we bring it down, it has a lower lifetime in the atmosphere. So it could actually make a bigger difference over a shorter time versus CO2, which stays in the atmosphere for a longer time. We of course have to focus on both, but our idea here of focusing only on CO2 and ignoring this could mean that we, like one of the speakers in the video said, will probably go over our limit for carbon equivalent greenhouse gases in the atmosphere just by continuing to eat the way we do. And again here, water does not contribute to climate change. It's the natural one that actually keeps our planet at a nice cozy temperature.